Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about intervals of concavity.
Minute Math, when you need help you use Minute Math.
We're given this problem right here. Y equals a negative 3 over 16 times x minus 1 to the 4/3 power minus 3/2 times x minus 1 to the 1/3 power plus 2. And we have to find points of inflection, discontinuities, intervals of the functions concave up and concave down. Now, one thing I noticed here, we're taking the third root. It's the only thing that's really going on here that could cause an issue. But that's 3 in the denominator of the exponent. But there's no values that we cannot plug in. There's no jumps going on what we know about these functions. So we can say right off the bat that no discontinuities exist. No discontinuities exist. Okay. Now, we need to find the first derivative and the second derivative to find the rest of our information. So let's go find the first derivative here. Let's go f prime of x here. All right, first derivative. Well, negative 3 over 16 stays out front. We bring down the exponent 4/3. Multiply that by the inside, x minus 1. Subtract the exponent by 1. And we have a 1/3 going on here. Multiply by the inside, which is just 1. Minus 3/2 stays out front. Multiply by the exponent 1/3. Inside stays the same, x minus 1. Exponent 1/3 gets subtracted by 1, which is a negative 2/3 now. Multiplied by the inside is just a 1. And the derivative of 2 is just 0. Okay, let's go clean this up a little bit. F prime of x equals, well, the 3's cancel right here. 3, 3, 4, and the 16 become a 4 right there. Okay, so we just have a negative 1/4 out front, x minus 1 here to the 1/3 power, and don't worry about that 1. Minus, well, the 3's cancel here as well, and so we have a 1/2 times x minus 1 to the negative 2/3 power, and we just have the 1, don't really need it. All right, we have our first derivative. Now, let's go find the second derivative. And I'm purposely keeping it separate right now because, well, that's the way I like to look at it and see it. Second derivative here, f double prime of x. Okay, f double prime of x. All right, we have a negative 1/4 comes down here. Then we have the 1/3 comes down, 1/3, x minus 1. Subtract the exponent by 1, and we have a negative 2/3 here. Times the derivative inside, which again is 1. Minus 1/2 times this exponent, negative 2/3 comes down. X minus 1, subtract the exponent by 1, and we have a negative 5/3 in the exponent, times the derivative inside, which is 1. Let's go simplify this where we can. Let's go, I'm going to move over here so I have a little more room. F double prime of x here. Well, let's make this as a fraction. Negative 1/4 and 1/3 is a negative 1/12, right? So we have a negative 1 in the numerator, and we have a 12 down here. I can bring this down to the denominator now, and we have x minus 1 to the 2/3 power, and it's a positive 2/3 power. I don't really care about that 1 here either. Subtract, well, the 2's cancel. That's always nice. And actually, we're going to be adding, because we have a negative, negative becomes a positive. Positive here. So we have 1 in the numerator left over. And we have a 3 left in the denominator. We have an x minus 1 to the positive 5/3 power. Okay. So what can we do here? Well, I want to combine this to be one fraction. Okay, and just like any fractions, we're going to do the same process. It's just a little more difficult. We have to find a common denominator. So I take my f double prime of x. I'm going to rewrite this function, but give myself a little space here. Equals a negative 1 over a 12, x minus 1 to the 2/3 power. And I'm going to multiply this by a x minus 1 over an x minus 1. Plus, right hand side, I have 1 over 3 x minus 1 to the 5/3 power. I'm going to multiply this one by just 4 over 4. Notice 4 times 3 is going to be that 12. We'll match up there. And then x minus 1 is like the 3 to the 3/3 power, right? Out of the exponents, we have the 5/3 power. So we can write this as one big old fraction now, f double prime of x here. And that comes out to be negative 1 times x is a negative x. Negative 1 times a negative 1 is a positive 1, plus 1. plus 1 times that 4, it's going to be the numerator, we have plus of 4 here. Okay, all over our denominator, which is just going to be a 12x minus 1 to the 5/3 power. Keep simplifying that. We have f double prime of x here. All right, and we have a negative x, and then 1 plus 4 is 5, negative x plus 5 here, and the denominator stays the same, 12x minus 1 to the 5/3 power. All right, we got the second derivative here, kind of looking nice and neat. Let's go find points of interest here, critical points here. So negative x plus 5, I'm going to set that numerator equal to 0, so negative x, let's separate this out just a little bit, negative x plus 5 equals 0, and that comes out to be, well, x equals a positive 5. What about the denominator? Same thing, I'm going to do that 12x minus 1 to 5/3 power equal to 0. Divide both sides by 12, take the power of both sides to the 3/5 power, it's just 0 here, and we're left with just an x minus 1 equals 0, and x equals a positive 1. So we have 2 points of interest here to do our second derivative test. We have it at 1 and at 5. That's really what's going on here, these two values. I'll circle them here for you. After all that, that's all we're really caring about. So we're going to plug in values into our second derivative, which we found right here, our second derivative, and see where they lie in our second derivative test. So I found f double prime of 0, and that came out to be a negative 0.4167. It's negative, that's all I care about, meaning we're concave down here. Between 1 and 5, I picked 2, so f double prime of 2 came out to be a 0.25. I just care that it's positive, and we're concave up here. Lastly, I pick a value bigger than 5, and I pick 6. F double prime of 6 came out to be a negative 0.0057. I don't care what it is, it's just negative. And it's concave down. All right. So we have inflection points at 1 and 5. So our inflection point at x equals 1 and 5, because look, we are changing concavities at 1 and 5. Good to note there. Okay, now we're concave up from 1 to 5, so we're concave up, and the interval from just 1 to 5, but we're concave down on the interval from negative infinity to 1, and from 5 to positive infinity. And so again, our final answer here is no discontinuities exist. Our inflection point is at x equals 1 and 5. We're concave up from 1 to 5, and concave down from negative infinity to 1, and from 5 to positive infinity. I hope this video was helpful for you. If it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.